let's, just to refresh your memory, the assignment, which is due the 15th, you can turn it on the 14th as the assignment sheet says, but the 15th will be fine, Friday the 15th, which is this Friday. You're going to do a two-way ANOVA, or two-way MANOVA, so two independent variables and at least three dependent variables and one or more covariates, okay? Does everybody have an analysis in mind? You've thought about this some? If you're a no, because I can think of a couple people who their ANOVA analysis didn't work out very well. They had sort of goofy things with groups where some groups only had 2 or 3 people and other groups had 150 people. So if you're one of those people, we'll have to come up with a different strategy for what you're going to analyze, because that will only become much more convoluted, complicated, and really not useful if that's what you do with the last homework assignment, okay? So I think I have us leaving off so we talked about some practical issues, and remember when we're talking about MANOVA, it's a two-step process. You're going to first assess what's going on at the multivariate level, and if you find statistical significant results at the multivariate level, then you sort of get the green light or the statistical rights to then assess what's going on at the univariate level, okay? So it's a two-step process. First, we're going to look at the multivariate level, and then we're going to look at, if we have significant results, we're going to look at the univariate level. If none of your multivariate results are significant, then you really don't have anything to report at the univariate level. So that's sort of the slides that precede this. 5 or 6 slides. That was a big part of that story, is just think of this two-step process. And actually the second part of that process is just interpreting ANOVA results. And we already know how to interpret ANOVA results, okay? So we just really have to learn what is the multivariate effects and how do we understand those. And then drill down to the univariate results where appropriate, and then interpret those results. And that is nothing that we haven't already done. So this is. Did anybody? We covered this last week, I think.
Yeah.
This was the last slide we had last week. Is that what your notes suggest? What's that?
The next slide, you're the procedure slide.
And this is where we. That's annoying. This is where we. This is where we left off, right? So the procedure, as I indicated, is first we determine at the multivariate level or the omnibus effects, and then if there are significant omnibus effects, we still have to look at the univariate effects to see. I am, yes, thank you. And then we have to look at the univariate results to see more specifically where the significant results are within the 3 or 4 or 5 dependent variables and the independent variables that you have that are part of your analysis. And that's what I'm saying here. And by default, that's what SPSS gives us. So it gives us the multivariate results, assess those, and then it just gives us ANOVA results, and we can assess those, just like we've assessed ANOVA so far. And this is, I know I've said this before, and I won't belabor the issue, but the ANOVA results that we get here are exactly the same. Degrees of freedom are the same. The effect sizes are the same. The F values are the same. The significance levels are the same. as if you were to run this ANOVA all by itself. Okay, there's no magic, there's nothing special that's happening behind the scenes once you get down to the univariate level. The only difference might be that your listwise n might be slightly different because the listwise n is determined at the multivariate level. And if you run univariate ANOVAs, it's the listwise n is determined at that level. And so you might find some differences, but the only differences you're going to find is going to be because maybe some participants were listwise deleted in the multivariate level that weren't listwise deleted at the univariate level. So I think that makes the process of understanding MANOVA much more straightforward because it really is just 2 steps, both of them quite straightforward. And your textbook spends a fair amount of the chapter talking about this other procedure. So this isn't the only way. It's just the way that SPSS does MANOVA results by default, but it's not the only way. It's the way that I think most people in communication, most people probably in the social sciences analyze and interpret MANOVA results. But there would be other things that one could do, and this is just one example. Is this what they call step-down ANOVA procedure, which is similar. It has a similar flavor to it, but it does have one important distinction. Can't do this with the point and click, but you can do it with a couple lines of syntax in SPSS. And in this case, what the researcher has to do, and this is difficult, and this is maybe another reason why it's not used very often, is because you have to prioritize your dependent variables. And oftentimes we don't have a priority, right? We have 5 dependent variables, all of them equally important in some, for a particular reason. Maybe they're all different. Maybe some are cognition, some are emotion, some are communicative in nature. But we can't clearly prioritize them in terms of a ranking. But this would require that you prioritize those and maybe take the one that you see as most important or most theoretically central, theoretically relevant. It would require that you take that variable and have it be the dependent variable. So this is after this is just another way to examine your results, and in this case, take a dependent variable, one of them of highest priority, and run an ANOVA with it, and then that dependent variable becomes a covariate in the next step down on the priority list of dependent variables. And what this would eliminate is situations where we have several dependent variables that are all highly correlated with each other. And the MANOVA results might suggest that that these are clear, concrete differences that exist across some group of dependent variables. But if we control for the highest priority dependent variable as we look at the results, these differences will not be prevalent. If all of the dependent variables are highly correlated, if we covary for some number of those, eventually that group of dependent variables will not, there'll be nothing there that will be significant after even just one step. So in the second step, or if not the second step, maybe the third step. So just another way, or just an indicator that there's more than one way to process multivariate analysis of variance or multivariate analysis of covariance. That this process that we're going to talk about isn't the only way. And so, as I indicated last Monday, the overall omnibus effects are assessed first, and that's done by creating this linear combination. And linear combination might not be terminology that you're familiar with, but if you think about a regression equation, which is something that you should be familiar with, or that you are familiar with, where we have some weight, which would be like a b, for example, in a regression, and then some score, which would be an individual's person's score on a particular variable, another way, all the way out to however many dependent variables we have. And this is essentially what happens at the multivariate level, where there's this linear combination where all of your dependent variables are grouped together with some weight, and we get this composite score. And then it's with that composite score that that the software determines, can I estimate which group somebody is in, which group of your independent variables specifically, which group somebody is in based on this composite score that they have. And if we can assess with some level of reliability, greater than we'd expect to get by chance, then the omnibus or overall results are thought to be or are considered significant. And so it's not anything that we need to spend much more time on, because we never have to calculate this. We never see it. It happens behind the scenes. But that is what's going on when we get our multivariate results. And it's the same thing as discriminant analysis. So you can find in SPSS, I don't remember what it's under analyze, but one of those menus, there's something called discriminant analysis, and you could get exactly the same results. You'd have to be a little bit careful, but your dependent variables would be the independent variables in the discriminant analysis, and then one of your independent variables would be the dependent variable, so that you just switch the two around, and you'd get exactly the same results at the multivariate level, because this is the work that's happening behind the scenes. For our purposes, what we'll just focus on is these multivariate tests that are associated with MANOVA. And there are several of them. In fact, SPSS produces these four for each of the independent variables that you have in your analysis. So if you have two independent variables, you're going to get one for each of the independent variables, and another set of these tests for the interaction between those two independent variables. And then you're also going to get this same set of tests for the covariates that you have that are part of your analysis. So, and these tests are based on this composite score that we talked about here just a minute ago. The next slide tells you a little bit, because this is by far the most popular test, Wilks Lambda. The other three, I've never seen anybody report. Hodeline's trace, Fly's trace gets used some, and Roy's largest root, I've never seen anybody report that either, and I'm not quite certain of the origin of that name, but I'm sure it has some significance. So the default reporting statistic is Wilks Lambda, and there will be a value for lambda, and then an F test associated with that value, and then a level of significance associated with that F and the degrees of freedom that you have for your particular analysis. And so it's not a lot different than what we have done so far. At the end of the day, the thing that most people look at first is not the value of this, but they look at the p-value, right? Is this effect significant or not? Is the p less than 0.05? So a little bit more about those multivariate statistics that were at the bottom of the previous screen. When your independent variable has only two groups, so male and female, for instance, all four of those tests are exactly the same. The p-value and the f will be exactly the same. With the exception of Roy's largest root, in most cases, the f for the omnibus test are at least similar enough. They're not night and day different. For whatever reason, Roy's largest root is somewhat of an outlier. It's always more liberal in its p-value that it reports, and so you might find that the p-value for Wilks lambda is not significant. Let's say p is equal to 0.15, and if you look at Roy's largest root, it might be p is equal to something less than 0.05, and so it ends up. It's really not much of a debate that you can have about should I report this as being significant or not, because nobody reports Roy's largest root. The reporting statistic that you should use is Wilks lambda, unless there are some significant violations to the MANOVA assumptions. For instance, maybe the multivariate test of homogeneity of variance is not met. And so this might be a case where you would report Fly's trace as opposed to Wilks lambda. But again, the results are very similar across all four of these, with the exception of this bottom one. And with two groups, all four of them are exactly the same. If you have three groups, there are some differences, but usually if this is significant, these two will be significant. If this is not significant, Wilks lambda, then the other two will not be significant. And then the last one, again, is somewhat of an outlier. Okay? Questions so far? So let's just, in the PowerPoint or PDF that I posted to D2L, does it have the output then for an analysis? Okay, good. So what I'll do is quickly run through how to do the analysis. I think probably most of you at this point could sort of figure out how to do the analysis without me doing this, but I'll do it quickly, and I think you'll find that it's very similar to everything we've done so far. And then we will just look through the results and sort of interpret those results that you have in front of you, and then that will conclude what I have to say about MANOVA. But it'll probably take us an hour or so to get through. Excuse me, to get through those results. I might add, just parenthetically, I didn't do an example write-up for MANOVA. It's going to be, the ANOVA part's going to be exactly the same as what you did for ANOVA when you get to that part of the analysis. The reporting the omnibus result is very straightforward. Report Wilks lambda, the value of Wilks lambda, an f that's associated with it, degrees of freedom that are associated with that f, and a p-value. Look at your textbook because they have, as you know, they have write-up at the back of all of the chapters, and you can see just a little bit, you can see a blurb about how they would report it, but the reporting is not all that much different than stuff that we have, stuff that we've already done for the most part, with the exception of that multivariate test that I just mentioned. Okay, so the analysis that you should have, and this might not be exactly the same, but it should be pretty close to the same. We're going to do, again, general linear model, but this time multivariate instead of univariate is where we've been doing ANOVA, but we're going to do multivariate. And I have female and party identification as the two independent variables. And then as for dependent variables, I should have, let me just refresh my memory. It's a bunch of media usage variables, right? And so it's how often they talk about politics in their home. It's how often they read the newspaper and read political stories in the newspaper. And it's how often they watch television news and political coverage on television news. And so this is data from the 2004, seems like forever ago, 2004 presidential election. And so it's how much they talk. And these are all, see, the political discussion is on a 0 to 7 scale. They never talk about politics, or every day of the week they talk about politics. So is newspaper. They never read a newspaper, 0 to 7. Every day they read the newspaper. But television news is measured on a different scale. The way that we usually measure whether somebody's consuming news is both exposure and then how much attention so because you can watch news or you can watch television and not pay any attention to it. So we combine both exposure and attention, and that's why, and it's a multiplicative combination, and so that's what the abbreviation for is in front of TV. So this is on a different metric. It's on a sometimes it's 0 to 28. I forget this one. It might be 0 to 14, but it's a different scale than the political discussion and newspaper. So your dependent variables can be measured on whatever scale. They all don't have to be 0 to 7 or 1 to 5 or 1 to 9. They can be whatever scale. You don't have to change anything. The analysis will be able to take care of those differences. During the computing of the. And then the covariates that I included were how interested the person was in the campaign prior to the campaign starting. And so we're going to just add those as covariates. And this is, remember we didn't do an assignment for analysis of covariance, and so this will be a new, slightly new, but it's pretty straightforward in terms of how to add them into the analysis, and then in terms of interpretation, we'll talk about that. This is when they were interviewed during the campaign. So the interviews start right after Labor Day, and they go up until the day before Election Day. And so the thinking is, when we get closer to Election Day, people are more honed in on the vote, and you just almost can't escape it, given the media attention. So we want to control for when they were interviewed, and then we also want to control for general political knowledge. So this is, do you know how many Supreme Court justices there are in the U.S. Supreme Court? Do you know who the senator is or senators are from your state, or who the Congress? So this is like textbook general political knowledge, as opposed to campaign specific. So it's stuff that doesn't change for the most part from campaign to campaign. And the questions aren't, it doesn't ask you who are the senators from your state, because that is campaign specific. It's who are, one of them is Supreme Court justices, one of them is who's the British Prime Minister, or they give the name of the British Prime Minister, and they see if the person can identify that person as, yes, that's the British Prime Minister. And then the other one is, I forget off the top of my head. Michael?
Can covariates be both continuous and like nominal, ordinal? Or do they have to be continuous?
Anybody want to take a stab at that? So covariates, what level of measurement? Continuous or? Yeah, very good. Yeah, so you can be, well, they have to be either continuous and or dummy coded nominal variables. So we could, as long as you dummy code it properly, you can include it as a covariate, even if it's nominal level data. Okay.
I think you already said this, but I forgot. You want 3 dependent and 2 at a minimum, 3 and 2, and then how many?
I say one or more covariates.
1 or more.
Yeah, and so one or
3 dependent, 2 independent.
yeah, so it's going to be a two-way MANOVA. is what you're going to run. So 2 independent variables, 3 or more.
3 or more dependent.
Yep, and if you have 3 to add 4, just will not be any more work. And so if you have more than 3, add more than 3. And then 1 or more covariates, yeah, and covariates are no work either, so if it makes sense to include 3, then just include all 3 of them because it will not increase your work by 3 times. Good. And so remember that the post hoc test gets grayed out when we add covariates, so this is not available. So we have to get our post hoc test somewhere else if we think we're going to need post hoc tests. Generally, we don't ever need to do anything with the model, but if you wanted to change sums of squares to something other than type 3 sums of squares, that's where you do it. And it's rare, if you don't know what you're doing, you shouldn't just test it to see what it does, because it's a completely different form of analysis. Whether you use type 1, type 2, or type 3. Type 3 is the one that they say we should use unless there's good reasons to do type 1 and type 2. Contrast is, again, something that we haven't done anything with. Plots, we can do, should we do separate lines for, we can do that, and we could also do this. This is maybe not what I gave you in the handout, but sometimes it's helpful to see which one makes the most sense. In terms of save, there's nothing we need to do there. In terms of options, descriptive statistics, estimated effect sizes, homogeneity test, okay? And the homogeneity test will give us both a multivariate homogeneity test and univariate homogeneity test. And then these will give us what our estimated marginal means. Anybody want to take a shot at that? We talked briefly about this last week, and maybe the week before I mentioned. So when we add these, when I do this, what's that going to produce for us? Means that are
estimated based on the accounting for no variance in the covariates.
Yeah, so it's holding your covariates constant, and it's going to be they're estimated based on that. So good. We don't really have the option in this dialog box to say we don't need post hoc tests. But Khalif, do we need post hoc tests for female? No, we don't, right? Why not? 2 groups, right? Yeah, so thank you. And then party identification, we would need it, right? We would need it, but we'll just have to do that. And we're going to get post hoc tests for everybody. It's not smart enough to, at least with the dialog box, to get. And then we could calculate our own Bonferroni easy enough if we wanted to, right? How do we do that? Either divide or multiply, right? I think I'd probably just count up the number of tests you're doing and multiply your p-value by that. Or we can just do this. Or you could do so it's whatever your preference is. And I think, what did I give you? Very, maybe not the most stringent, but LSD is no stringent. LSD is, yeah. LSD is no adjustment at all. And so Bonferroni is maybe not the most conservative. What's the most conservative? I think, Cameron, what was the one that you asked about? I think for some reason it sticks in my mind that, what's that?
Tukey HSD.
And I don't know what,
Two keys, right?
I can't answer that. But it seems somewhere in the back of my mind, Tukey's is thought to be more conservative than Bonferroni. But we're going to just do LSD, or we're going to ask for LSD, and then we're going to see what we get, okay? We're good?
Can you? So you're having to do a post hoc test here. Why is post hoc grayed out?
Because I don't have a really good answer for you other than it only grays out once you slide in the covariates.
Yeah.
And so there's something about when you include the covariates in the analysis, those post hoc tests that are on that menu are calculated in a different way that are not appropriate for the use of covariates. And so there might be some ways to get around that with syntax, but that's always been my not, I've not researched it, but that's just sort of my anecdotal understanding of why it grays it out is because those tests are not appropriate. The way they're calculated with the use of covariates, these would be, okay?
Okay.
And then that's it. And we'd have output that should look sort of similar to what you have in front of you. And you can't read this very well at all from where you're sitting, but you have this in front of you. So we're going to just use this kind of as a marker, and I'll point some things out as we work our way through the analysis. And I can use the mouse so that when you watch the video, I'll try to remember to use the mouse. So if there's a bunch of stuff on the screen, here there's nothing on the screen other than that one table. But if there's a bunch of stuff on the screen, I'll try to make sure that I highlight where the thing that we're discussing. So if you watch this on Thursday or Friday, it will still be there. So this is simply telling us the number of males we have and the number of females. Group sizes are fairly equal. I wouldn't expect it to be exactly equal. And what we want to avoid is having, what if we had 15 males and 1,050 females? Would that be a good ratio of males to females? You need to find a different grouping variable besides. Why is that a problem? Why would that potentially be a problem? Let's say we have 15 males.
So we have a group with no males in it.
Yeah, so when we slice across Democrat, Republican, and Independents, we could easily then have, because that 15 is going to have to divide across, and if we get lucky, well, I don't know how lucky it is, but there might be 5 in each of those groups, but probably not. And so you could end up having empty cells, and 15 compared to 1,050, it just feels bad, doesn't it? Or odd, or not right? And so you should sort of go with that instinct, and if that's what you have, we should reassess the analysis both for this homework and for future work that you do. Do they need to be exactly equal? Of course not. Not with the framework that we're using. Does anybody know the term that they use when the cell sizes are exactly equal? There's a term that people who do they call it a balanced design. And I don't know why they say it's balanced, meaning the cells are all equal n. And we have, in this case, unbalanced, meaning the n's are not. And so the unbalanced, I don't know why they just don't say equal n or unequal n. I guess they like the word balance, or somebody liked the word balance better. But that is what a balanced design is. But this framework, under the general linear model, does not have any problems at all dealing with unbalanced designs. But from a practical point of view, we don't want to have differences that just feel out of whack. There's not I can't give you a number, but if they just don't feel right, then I think you should reconsider. And then Democrats, Independents, and Republicans, I think I don't have any problems there. Usually in the population, we think about these groups as being a third, a third, a third. Independents actually behave very much like either Republicans or Democrats. They tend to be fairly consistent in their voting patterns, and so sometimes people will they'll ask independents if they lean towards the Democratic side or the Republican side, because if they're a Democratic leaner, in 99% of the cases, that's how they vote. If they're Republican leaner, then 99% of the cases, that's how they vote. And so that's just what that little note is to myself, that when I constructed that variable, I included leaners, people who say they lean Democrat or Republican, and some people would just take those out and either make them Democrats or Republicans in terms of the analysis. This is the marginal and cell means for each of our dependent variables. And we can see that, so this is people who talk, and males are 2.67 and females are 2.62, right? So males tend to talk about politics a little bit more than females, right? I'm getting that from this line right here, this bottom line, 2.67 for males and 2.62 for females. And then we can look across that for Democrats, Republicans, and Independents. And it seems like Republican males, am I looking at that right? Republican males are the most talkative, right? Because Republican males, again, 0 is male here. Is it 3.11? And that's the highest amongst those 6 values. And so, and then we can see the N for when we slice the groups by both, whether they're male and female, and party ID. So we can see that our N's are still fairly, at least they're not equal size for sure, but they're at least high enough where I don't wonder if there's enough people in that group to properly represent, males who are Republican, for instance. And then, so we have the data for newspapers. Males tend to read newspapers more than females. And of the males, Republicans, actually Democrats read the newspaper most, right? We don't know if it's significantly different. This is what we're testing, right? We don't know if it's significantly different, but just if we look at the raw numbers, for females, it looks like the same is true, right? Democratic females who are Democrats tend to read the newspaper more. We don't know if it's significantly different, more than independent or Republican females. And then we could also, of course, look at the main effect for party ID, which is what this is testing. This would be the main effect, and then when we start to drill down to this level, we're looking at the post hoc test. And then I won't go through newspaper, but we could make some of the same conclusions about newspaper. So far, so good, easy enough. This is the multivariate test of homogeneity of variance. So this is akin to Levine's test that we use and we'll get as in the next couple slides. And in this case, just like Levine's test, we want to have it be not significant, right? Which means that our variances at the multivariate level, in this case, do not vary significantly, right? So testing the same thing as Levine's test, but in this case at the omnibus level, the multivariate level. So the preference would be to have this less than, greater than 0.05. If it's not a fatal flaw. You'd want to report that your data does not meet that criteria, and potentially report Feli's trace instead of Wilkes lambda for the multivariate test. And you can take a look at your textbook again to see the blurb that they mention about when to use Feli's trace and give you a little bit of some of the wording that you could potentially use there. Okay?
Wait, did you say that had to be greater than?
Yeah, so we want this to be non-significant. We want this, just like Levine's test,
Okay.
greater than 0.05 is we want to fail to reject the null hypothesis. We don't want them to be different. We want the variances to be equal or not significantly different from each other. And so this is the test of, this is the first important table, and these are the multivariate tests that were run for each of our covariates, for our two independent variables, and for the interaction, okay? So this would be the first table that we'd want to spend a little bit of time digesting. Because based on this table, we'll get the, we'll find out which ANOVAs do we need to examine, or which parts of the ANOVAs do we need to examine. And this doesn't tell us anything about whether it's newspaper or political discussion or television news. It's only looking at the group of those things combined. In our case, those three things combined. And in your case, if you have three dependent variables, it'll be those three things combined. So it doesn't tell us anything about which of those three are significant. It only tells us that, hey, there's something going on at this level with one of the variables. And so the place that I would always start is with the interaction. And in our case, the interaction is not significant. The p-value is this value right here. If we're going to use Wilks lambda, it's this value right here, 0.419. It doesn't allow me to highlight just one row, so I have to highlight a whole bunch of rows. But this is the value of Wilks lambda, 0.994. This is the f value, small f, essentially 1. With 6 in 2050 or 2060 degrees of freedom, I think it's 2060 degrees of freedom. And the p-value is 0.419. Do you think you would report the effect size when it's non-significant? It really doesn't make sense to report it because you just told me here that this doesn't vary significantly from 0. So the effect size is usually not thought to be required when reporting, not just in this context, but in any context. Some people might sort of quibble, well, it would still be useful to have, and there might be some uses for it, but I would say as a general rule, there's no need to report it. So we don't have to worry about the interactions across any of our three dependent variables. That's what this is telling us because at the multivariate level it's not significant. Okay? Does that make sense?
Say that again, we don't have to worry about any of our.
We don't have to worry about any of the interactions between our independent variables at the univariate level because at the multivariate level they're not significant.
I see.
And then you can look at the female and party identification and see that they are significant, right? But again, it doesn't tell us just because this is less than 0.05, right, for Wilks lambda, just because that's less than 0.05, that doesn't tell us anything about are males and females different for newspaper, for television news viewing, or for political discussion. It doesn't answer that question at all. It only tells us at the multivariate level, if we group all three of those together, does there appear to be some differences that help us to put people into a group as either being male or female? And in this case, the answer to that question is yes. Based on that composite score, we can, not with complete certainty, but with greater than chance certainty, put people into a group of either being male or female based on their scores on newspaper consumption, TV news consumption, and how much they talk about politics. And then party identification, sort of the same story, right? But there's really two more levels to party identification because we have party identification, and there is an omnibus effect or multivariate effect, right? And so then we have to drill down into the ANOVAs and find out, well, is it newspaper reading? Is it television news consumption? Is it political talk, political discussion? And then after we find which of those three, or maybe all three of those dependent variables are affected, we have to determine, well, is it Republicans significantly greater than Democrats, or is it independents significantly less than Republicans and Democrats? So we have to, in this case, because our group size is greater than 2, we have to sort of drill down one more step, just like you would do with ANOVA. So when you do an ANOVA with just 2 groups, like we had with male and female, no need to do post hoc tests. All you have to do is look at the means. If it's significant, then you can just look at the means and you know the direction of the difference. That's not the case with 2 or more, or more than 2 groups. You don't know where the difference is. Is it 1 compared to 2, 1 compared to group 3, or 2 compared to group 3? You don't know which of those. Maybe they're all significantly different than one another, or maybe just one of them are. And so in the case of party identification, we'll really have 2 more, after this level, 2 more levels of understanding to get to in order to make sense of our data. So far, so good? And then the only thing I haven't looked at is the covariates yet. And this one might start with the covariates instead of like I did with the interaction. You certainly would want to do the interactions before you do the 2 main effects. Why is that? By the way, that would be a good question for an in-class exam, wouldn't it? Why would you, don't write it down though, or write it down, I don't care. Why would you look at the interaction in ANOVA? Why would you look at the interaction before you look at the 2 main effects? Bobby?
Because the main effects are being qualified by the significant interaction.
What does that mean?
I don't know what I mean.
Yeah, that sounded really good, yeah.
The main effect,
And you're right, I think you know what it
the
means.
main effect of the IV on the DV is only significant, or is moderated by a third variable that is acting
Which is the other-
in conjunction they
yeah.
affect the dependent variable.
Yes, and so that's it exactly. And so it's that the independent variable in our case, if this was significant, party ID may not be consistent. If our interaction was significant, party ID may not be consistent across whether somebody is male or female. And we're going to talk more about another word for interaction is moderating effects. So we're going to talk more about that yet today in a regression context. But it's very applicable logically, theoretically, and actually mathematically, very similar to what we have here.
Can you explain that one more time?
What part of that?
When you explained what Mike just said. Where you
Can
said,
Mike say what you just said?
So you have your independent variable and your dependent variable, and the interaction means that there is a third variable that the third variable and the independent variable together act to change the dependent variable. So if you look at just the main effect of the independent variable and the dependent variable, that might not be the whole story. There has to be, or there is something else that's affecting that relationship. And so you look at the relationship between the 2. I'm not making sense at all.
No, I think you said.
Because if you look at the independent ones first, then you're right, you're missing out on the relationship between the 2
Right.
independent variables in terms of the dependent variables. So you need to see whether first that interaction is significant. If it's not significant, then you look how each one is affecting the dependent variable.
Right, and because if this in our case is not significant, so we don't have any it's not of interest to us for this discussion. But if this was significant, then the influence of party identification, shall we stop? Then the influence of party identification is not consistent across whether somebody is male or female, or whether somebody is male and female is that influence on one of our outcome variables is not consistent across whether somebody is Democrat, Republican, or Independent. And so that's why when Bobby said it's qualified by, it determines the nature of the effect of your independent variables or your main effects by themselves. So we're going to talk more, and there's a couple sort of helpful ways to graph interactions, and we've seen some of those. And so I think as we move forward, if it's not clear, I hope you'll ask more questions and we can pick it back up then. But getting back to sort of the sequence of events, we could have started and looked at our covariates first. That might have been a place to start. I started with the interaction. But if you do decide to look at the covariates first, then the very next thing you should look at would be the interaction. And then if that's not significant, you can look at the two main effects. So whether you look at the covariates first or not is really a matter of personal preference. In our case, whether all three of those are significant, right? All three of the covariates are significant. What does that mean? Significant. So the pre-interest just means how interested were they in politics prior to this particular campaign starting. If that's significant, we found that to be the case. What does that mean?
It explains some of the variance in the dependent variable.
Right, and so it explains some of the variance in the dependent variable. In this case, we don't know which dependent variable yet. We can find that out here shortly. But in this case, we don't know which dependent variable. It might be all three of them. My guess is in this case it will be all three of them. But it could just be one of them, or it could be two of them. There could be a remote chance, like this one here is Bobby, is that significant or not? Okay, right, and so this is the very interesting, and I think in this case I would agree that because we're doing so many tests, one might want to be really careful about, if you were to do a Bonferroni correction on this, it's not even close to being significant, because we're doing for this analysis, we're doing, I'd have to take a minute to calculate, but 25 total significance tests, and just the chances of making a type 1 error have increased. And so I don't know what most people would do, but it's at least worth thinking about and remembering what Bobby would do.
This is probably, getting ahead, but one thing that we did in the IARPA analysis that we would do, we had so many different covariates, so we would put all of them in there at once, and then we would run the analysis again with the non-significant covariates removed, and then assess it again. If any more were non-significant, we remove them again, and so we pare down our covariates that way to ultimately get what are the significant covariates.
Theory didn't help you determine what those covariates should be, obviously.
The government told us what the covariates.
But then obviously you went against the government wishes, right? And you.
Well, we said we ran it, we measured them, we included it, but then they were non-significant, so we threw them out.
And then you just told them that, hey, these didn't work. So yeah, and that would be, I know. Well, I've seen that. Usually you're not faced with some bureaucrat telling you that you need to have these covariates. It's just theory sort of driving it. And then I think you should make an argument as to why you need these covariates before you ever run the analysis. Put the covariates in, and then leave them in, and then maybe inform future research. Inform future research. They might have the same thinking that you have, but if you can tell them that, hey, this covariate doesn't matter when this is your dependent variable and these are your independent variables, it might be useful for future researchers. So, but I do know people who would, even in that case, just take them out because they do reduce your degrees of freedom, and they're not really caring. They're not doing anything in the analyses. So it's a matter of personal preference. But I think one should determine upfront, as you guys did, what covariates are needed, and then only include those. The thing that it seems like, and I know I've mentioned this before, but I think it's worth mentioning again. When I read research, and I know this to be a fact, not just from the research, but from asking people the question, they run the analyses and they don't find any significant results. And so they head out on a fishing expedition to see what they can do to resurrect something out of their dissertation data or out of some data that they spent a long time collecting. And one of the ways that ends up working is they put in covariates that really don't seem very intuitive and maybe don't fit in very well, but when they put them in, their results pop. I've heard people say that word before, that their results pop. And I find that to be, if you're honest and report that, this is what we did, then I'm good at that. And if it gets published, great. But to present your data as from the get-go, you decided that these covariates need to be in, and this is how, to me, it's a little bit disingenuous, and a little bit is being charitable. It is disingenuous. And so I personally would be careful with making those kinds of judgments, sort of post hoc theorizing, post hoc trying to get something out of your data.
If you got a manuscript to review and you saw like, well, we ran all these things and nothing came out, so we went back and added some covariates.
I'd be like, yeah. Well, it depends. I don't know about fatal. It's too strong of a word, I think, but it doesn't bode well, right? But I don't think fatal. It just I think it depends on the merits of what else the research did. Maybe they contributed something very unique and something very meaningful, and so it wouldn't be a fatal flaw. But sometimes when you read research, you just have a sense that, boy, that's an odd group of covariates. It just doesn't seem intuitive, and it can be work that in the same area that I do research, and it just doesn't seem intuitive. I wonder how they came up with that group of variables, and it might be 7 or 8 covariates, and it just doesn't take rocket science to figure out that it was not sort of premeditated. It was sort of post hoc, sort of worked out. So, are we good here? So in our case, all 3 of our covariates are, well, 2 of our covariates are definitely significant. Is p equal to 0? P is less than 0? Less than what number? What would you use if when you do research and you get this? What number do you use? P is equal to 0?
Less than 0.001.
Yeah, right. Because it's just rounded to 3 decimal places, and P is never equal to 0. Don't ever write. Please don't ever write P is equal to 0. People do, and you'll see people do it. It's not equal to 0. It just happens to be that SPSS rounds it to 3 places, and it's reported as 0 here, but it's not. It can only approach 0. It will never be equal to 0. We're good? So what our next step would be, okay, I don't have to worry about the interactions. I'm going to look at my 2 main effects for whether they're male or female, and whether they're Democrat, Republican, or independent. These are the Levine's tests for the individual ANOVAs. This would be the exact same Levine's test that you would get if you did the ANOVA by itself. Again, the only difference would be is when you do the MANOVA, your listwise n, the number of people in the analysis, is going to be based on all of those variables that are in the analysis, including the 3 dependent variables. If you did an analysis for just political discussion, your listwise n might vary some because there might be some people that are missing or not missing at the univariate level. So that would be that's the only difference. All of the other results are exactly what you'd get. Exactly what you'd get is if you ran the ANOVA all by itself. We just did this upfront multivariate part in an effort to try to ensure that we don't make type 1 error, that we're not finding results because we're running a large number of tests across a number of dependent variables. And so that's sort of the protection that you get at the multivariate level. But none of that is the case when we get to this level. So if we look at whether the female factor, we can clearly see that only one of the dependent variables, one of the three, was significant, right? So in this case, we know that males or females. Anybody remember from the previous table that we looked at? Anybody want to hypothesize before you look forward? What's your hypothesis? Who watches more TV news?
Republican males?
No. This is just males and females. No interaction. Just males and females. Men are more television. We'll see if that theory or if that hypothesis is true. I don't think it is, but let me. So we have to remember this, and then we only have newspapers for part identification, right? So that at the end of the day, those are the two significant results that we have. No significant interactions. One, and even if there was something, what would you do if there's something significant here? Let's say something was equal to 0.051. What would you do? Forget about being what Bob would do for a second. But what if this was equal to 0.051 right here? What would you do? And we got the results that we got at the multivariate level, right? The results that we got at the multivariate level was this was not significant, right? And it could be that this might be equal to 0.051. What would you do?
Don't look at it.
Exactly, or look at it but don't report it as non-significant, because if you're going to do MANOVA, you need to stick with,
The model.
Yeah, you need to stick with, and you need to stick with the procedure that you think is the best, that you adapted. And if at the multivariate level, and it happens sometimes, it's usually that kind of quirky thing where p is equal to 0.051 or p is equal to 0.06, so it's just right on the margin. But if you're going to do MANOVA, you just shouldn't report this as being significant at all. And usually it's consistent. If your multivariate effect is non-significant, the univariate effects will be non-significant. But it's not always that. That isn't always the case. So that's essentially what we have. We can think about, and we might. Usually the covariates aren't. We're not making hypotheses about the covariates, so we're not testing hypotheses. They were just in there as a necessary theoretical constraint, theoretical decision. So we probably would want to, if it were me, I'd probably just report, because all of our covariates, no, they're not quite right. The covariate is significant for, all of these are significant, right? I was looking at the intercept. All of these are significant for interest. All of these are significant for general political knowledge. Only interview day, but was this the one that was 0.051? The covariate for general political knowledge? Or interview day at the multivariate level. So we would, depending on your take on what you should do in this situation, you would either report this as, if you're going to say that 0.051 is significant, you're going to make that judgment. Then you'd report that political discussion is also significant, meaning that, well, I know in this case what it means is as we get closer to the election, people naturally talk more about the election in their conversations that they have with their coworkers and friends and family. But if you were to say the multivariate effect is non-significant, if you were to say that 0.051 is not significant, then you would just report that, and you wouldn't have to report anything for interview day. But if it were me, what I would report is these, but I'd put them in a footnote probably. I wouldn't take up the text of my results section where I want to focus on, where my hypotheses were, because I'm not making hypotheses about these, and they're not the main interest. So I would just put these in a footnote and just report which of the covariates were significant, but do that as separate from the rest of the report. So far, so good? Questions? Last part of the first, this is just the last half of the previous table that we looked at. These are estimated marginal means. Which of the three dependent variables were significant for male and female from the previous page?
Television news.
Television news. And so we can look here, TV news, and we can see that female's coded 1. Female is 10 point, make it 11, and male is make it 9.7. So females watch significantly more television than males when we control for the covariates that are part of the analysis. Does that make sense? Does the interpretation, not sort of the, forget about whether you think females watch more TV or not that part, but how we came to that conclusion? Does that part make sense? Okay. And then what do we do with political discussion in newspaper? What do we say about that?
Was there a p-value, using the p-value from the other table to say that difference is significant?
I'm sorry, Jackie?
So you use the p-value from the other table that tells you that the difference between 9.7.
Yeah, so it's very good. So it's this dependent variable we can see is less than 0.05 with 1, and the other degrees of freedom is on the other page. So 1 and whatever that degree of freedom is there for the air. And F is equal to 5.32. P is equal to 0.021, and P is less than 0.05, however you want to say that. And partial eta squared is equal to 0.005. Is that big? That's pretty small, right? We have fairly large n, couple thousand maybe. And so we have lots of power. And nothing, it's small, right? But it's greater than we'd expect to get by chance. But nothing to dance on the tabletop slope. All right? Does that make sense? So I think that takes care of everything that we have to do here. Now we just have to understand what's going on with newspapers, right? And SPSS gives us a whole bunch of output. So these F tests are exactly the same. These multivariate tests are exactly the same multivariate test. If you look at the Wilks lambda values, they're going to be exactly the same. And by the way that you interpret, so this Wilks lambda, that value is 1 minus the effect size, partial eta squared. So 1 minus 0.008 is 0.992. And so that's when people report Wilks lambda, it's useful at the multivariate level. It's 1 minus the effect size, And so it's variance not explained, and you could usually get variance explained from that. And then Fly's trace, it is the value of Fly's trace is the actual effect size. And most people will report the value for Wilks lambda. I might have said this already, but most people will report the value for, at the multivariate level, they'll report the value for Wilks lambda here, this 0.992, with, this is the F, 2.667, with 3 and 1,030 degrees of freedom. That's the level of significance. And then this is the multivariate effect size, and people would also report a multivariate effect size if it's significant, okay? These are the same F. These are the same F values that we looked at earlier. So this is for female. If you go back up and look at so this is where SPSS defaults to giving you, my theory would be just minimalist, just give me no output and let me request the output that I want. But SPSS just gives us all kinds of output and redundant output. So we've already got this once, and this is just the same information. You can go back up and verify it's exactly the same. These are the these are the univariate Fs that we just looked at. So, and again, redundant information. Just don't let it, don't interpret it as something different. It's just the same information reported in a slightly different format. And then this is the next factor, our second factor. And the significant difference there was for newspapers, right? And so we have these three estimated marginal means for newspapers. And without looking at which of those groups are different, we have, it looks like Democrats read newspaper more than the other two groups. But we don't know if Democrats are different than Republicans. Well, surely that has to be one of the differences. But so the question is, are Democrats significantly different than independents, right? Because this is the largest difference. You would think that difference between 2.748 and 2.183, that would have to be, if this overall thing is significant, that difference would have to be significant, one would think. But we can look here and find out for certain with this table where the differences are. But these are the means that were tested in our analysis of covariance. And these are the post hoc tests. And what would we conclude from the post hoc tests?
Just between independent and Republican, they're significant.
Democrats are significantly higher. Democrats read the newspaper significantly more than Republicans, controlling for covariates. How about Democrats and independents? Is that significant? How about independents and Republicans? Not so. It's just that one difference that led to that significant result. Okay. So at the end of the day, that's much of what we had to say for this analysis. We did the multivariate.
Could you say that again? Results?
Yeah, so Democrats and independents, that difference is not significant. It's 0.061, and if you were to apply this is no post hoc test. If you were to apply some kind of Bonferroni or even a more liberal correction, that's not going to be significant by anybody's standards. Democrats and Republicans, this is the mean difference, meaning Democrat minus Republican. Let's say independents, Democrat minus Republican, Democrats minus Republican. The difference is 0.565, and that difference is significant. But again, no correction at all for multiple comparison. One would have to add that, apply that to that if they were so inclined. And then the third one is independent. We already did Democrats and Independents, but Independents and Republicans. That difference is not significant, okay? Questions? So in our case, we ran the multivariate MANOVA and really only found two differences, right? No interaction, and at the univariate level, only females being greater consumers of television news than males during the campaign after we control for our covariates, and Democrats being consumers, larger, higher consumers of newspaper campaign coverage than independents, than any of the other two groups. Does that make sense? So really a lot of work, I don't know about a lot of work, a lot of detail to get to those two fairly trivial isn't the right word to use, but not earth-shattering results, and maybe that's reflected somewhat based on the data that I'm using. So questions on this again is just the same. In this case, these are the multivariate tests for PID, and if you go look at the multivariate test that we looked at the very beginning of the output, exactly the same. And these are the ANOVAs, again, just duplicate output. Any questions on MANOVA or MANCOVA? Any questions on your homework?
Do you want to see, and I'm sorry if you've already answered this, but like the profile plots and is there any sort of chart you want for the homework?
No, but I think you would want to, if the interactions are not significant, you don't have to interpret, you can just say interactions are not significant, unlike what I think I had you do with the ANOVA homework, where whether it was significant or not, I had you. So if the interaction is not significant, you don't need to have any plots. But I think whenever you do ANOVA or MANOVA, you need to always give the means that are being tested, even when the means are not significant. So whether that be, probably the best way to do that would be a couple tables. Maybe, well, you could do it in 3 different tables, one for each dependent variable, or maybe you could be fancy and combine that all into one larger table that has all 3 of your dependent variables. But if that is what you're testing, I think it's incumbent to report, because that needs to be a part of the, whether they're significant or not. And then if you're including covariates, which you will be, don't report the raw means, report the estimated marginal means. Report the means that have been adjusted for, your covariates, right? So don't report the ones at the very top. Don't report these means because these are the so-called raw means. They have no adjustments for covariates. When we get to the estimated marginal means, which is what these are, and the estimated marginal means, and it tells us that it made the adjustment for covariates. These are the ones that would be more important to report. Okay. Good question. Other questions, Michael?
That with the multivariate test, and if there's no significant interactions, we just stop there, or
So in our case, there was no significant interaction, but we didn't just stop, right? We then went on and looked at the main effects, right?
and then if that happens, like we can only look for main effects.
If your interaction is non-significant,
Yes.
then the only thing that makes sense to look at then would be your main effects. Because that's all that would be left, right?
Okay, like then if the interactions are significant, like
Yeah.
then what will we look at then?
So if the interactions are significant, then you will go and look at the. I'm going the wrong way. So let's hypothetically say that this is less than 0.05, the multivariate interaction, right? And then the next step would be just like we did with the main effects. We would drill down to sorry. We would get to this table, which I made it look like it was like 50 clicks away, but it was really just 2 clicks away. We'd get to this table and we would then look at the three, in our case, 3 dependent variables and determine which of those 3 are significant. Maybe all 3 of them are, or maybe just 2 of them are, or maybe just 1 of them are. And then you would report that interaction, just like the interaction, and I did give you an example of how to report interactions in the MANOVA write-up that we did. But if your interaction is significant, don't worry about doing the simple effects analysis for it, unless you are so inclined, okay? Because it wouldn't be impossible to do, but it'd be a little bit more difficult because the multivariate nature of the analysis and the listwise and might be different, and you can't do the simple effects analysis at the multivariate level. Would have to be done at the univariate. So if you have significant interaction, you would just report that, show a graph for the interaction, and you could essentially then just describe the nature of that interaction based on that graph. You don't have to give significance test like we did when we did the simple effects analysis, okay? Did that answer your question, Michael? Other questions? Other questions?
And just as usual, I'm assuming that for the SPSS syntax, you want it to be just what you need. I mean, instead of all 10 pages of output that it gives us.
I'm good if you just run the MANOVA sort of like I have here, and even though it gives us the sort of some of the redundant, gives us the F tables and a couple different, I'm okay with you just including that, not trying. You don't have to worry about deleting those tables. But if you have to do a whole bunch of other work to get your data, I don't need all that stuff.